to check on learning for sections 1.3. Remember, this is kind of an optional video. You don't really have to watch if you don't want to, but you are responsible for completing the problems right here. So this video is kind of meant for, you should try the problems first, and if you can't figure them out, then you can come back, watch this video, skip parts of it, go to the problem that you actually need, and then watch that part so that you're a little bit more ready for class. But again, if you got all the questions right, or you're confident with them, then you don't really need to watch this video. But here it is anyway. So question number 1, how is the graph g of x related to the graph of the given function f of x? So we've got f of x plus 7 is inside the function, so I know right now that's going to be a horizontal thing. It's a plus or minus, or I guess it's not a multiply by, so it is a translation, so the whole thing moves. And remember on the inside of there, I can even show it to you. Whoops. There you are. Since it's on the inside, there is that negative sign there. So this is going to be a horizontal translation to the left. 7 units. So same question, how is the graph g of x related to the graph of the given f of x? So again, it is inside, so we know that it is a horizontal. We can look at our handy dandy chart and go, okay, that is our 1 over b. So if I were to take the long way around, so our 1 over b equals 4, so our b is equal to 1 over 4. Go gadget algebra. And so our b is in between there, so it's a horizontal compression by a factor of 1/4. How's the graph g of x related to the graph of the given function f of x? So the negative sign is on the outside, so because it's on the outside, we know that it's an up or down or a vertical something. So then it's a negative sign, so we know it is a reflection across an axis. And since it's reflecting up and down, we know it is a reflection across the x-axis. Again, you can find it using this chart. Okay, so looks a little bit more fun. Describe how to transform the graph f of x shown to obtain the graph g of x equals all of that, and show the graph including the effect of each parameter of the graph of the image. Also include the effects of each parameter and the coordinate of the reference points shown on the graph. Okay, so it's part A, B, and C. So part A, let's label our letters, our parameters. We'll start with that. There it is. Move this out of the way. So our function is right here. So let's write down what we've got. So on the inside of our f, and again, I'm just moving left to right, so there's nothing on the outside. In the front, there's a -2 on the inside, so that means that our b is equal to -1/2. Okay, following why that's not -2. And then we've got our h is 0, and then our k is -4. So it moves down 4, reflected across the y-axis and compressed by a factor of 1/2. Hopefully I said y-axis when I said. So reflected across the y-axis, compressed horizontally by a factor of 1/2, and translated down 4 units. Okay, I agree to that one. So which of the following is the graph of g of x? So there is, do they put the original in all of these? That would be convenient. They do, look at that. Okay. So we're looking for a graph that is a little bit squished, moved down 4 units, and flipped across the y-axis. So this one is a little bit squished, moved down 4 units, and it's also moved to the left. We don't want that, do we? No, we don't want that. So let's see here. Which one is our original? So this one is not flipped across the y-axis. This one is not moved down. Oh, this one actually might be it. I'm sorry, I think I said that wrong. So this one is flipped across the y-axis and then moved down 4 units and squished by a factor of 1/2. So if we look at this line right here, it's 8 units long. This line is then 4 units long. And this one is flipped around the x-axis, not the y-axis. So I like that one pretty good. And then what are the effects of each parameter on the coordinates for the reference points shown on the graph of f of x? So they have the reference points on here. So I'm just going to use those letters, or those numbers. So 0, 0 moved down 4 units and then was reflected, so it's still 0, -4. 0, -4. 4, 8 was reflected and then moved down. So that is now -2, 4. -2, 4. 6, 8. And then it's going to be squished a little bit, so that's this point right there. So -3, 4. And then 8, 0 is this guy down here. So -4, 4. Or, I'm sorry, -4, -4. Where did my next button go? Move it, head. All right, last but not least, we had so much fun with that driving one. Let's do another one. Francis takes an urban standing scooter on a 2-mile trip at a constant speed of 10 miles per hour. The function, I guess their speed function based on time is 10 times t. No, that's the distance function. Represents the distance traveled as a function of time. What function represents the distance remaining of the trip? So we've got f of t. So it would be 2 miles minus 10t, or f of t. So 2 miles minus 10t. How can you write this as a transformation of f of t? 2 minus f of t. Or, yeah, I don't see that one. I was going to say, you could also say like negative f of t plus 2. Might make more sense if we're trying to graph it, but whatever. So drag the words, the numbers to complete the box. Okay. The graph of the distance remaining is the graph f of t reflected in the so it's a negative sign on the outside, so it would be, goes up and down, so it would be reflected around the x-axis and translated up 2 units. Yeah, I'll go with that. I like it. So there you go. Those are your check on learning. And we will, of course, do more in class. I'll see you there.